This was motivated by the awarding of a problem on the well-known PreMath Channel, and their problem was find the largest natural number not exceeding, and it was a binomial squared. It was completely arithmetic, and you weren't to use a calculator. Well, I amped it up a little bit. This is a binomial cubed, and again, no calculators. You have to do this by hand, and this language right here, find the largest natural number not exceeding. Okay, that's fine and that's clear. That's 7 words, but that means the very same thing as this symbol right here, the floor function. This is called the floor function, folks. That those half brackets, I guess, half brackets is what symbolizes the floor notation. Now, there's a property up here of floor functions that come in quite handy. There's a relatively quick proof right here. I won't go through that because this is more of a computational video. But it says the floor of any real number plus an integer b is just equal to the floor of that number plus b. And that makes sense. An example would be like if x were the approximation for pi 3.14. Okay, well, this would be 3.14, and we'll let b be 6, say. So that'll be 9.14, then the floor of that is just 9. You chop off the fractional piece or the decimal piece. Well, you can see that that's true over here too. If you take the floor of 3.14, that's 3, and if you add the 6, you get 9. So the integer just comes out, and that actually comes in handy in this demonstration. Now, so we're trying to find the largest natural number not exceeding 6 plus the square root of 11 quantity cubed. Now, so since this is a cubing expression and it's a binomial, we'll be using this result right here. Fairly well-known result. It says a plus b quantity cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. You can multiply all that out by hand. It's a well-known pattern. We're just going to use the result. Now, so we keep this in the floor notation right here, and notice that we expand it out, and we're just leaving it inside the floor notation all the way through. So using this result right here, you get 6 cubed. Now notice the 3's here. There's a 3 there and a 3 there. Those are exactly this 3 and this 3. Okay. Now again, this is very arithmetic, but 6 cubed, you see this 6 cubed, that's the 216 that you see right here. That's that 216. Now, where did this 198 come from? That's a little mysterious, right? Where did this 198 come from? Well, notice here we got kind of lucky. This says 3 times 6 times the square root of 11 squared. Well, that's just 11. And 6 times 11 is 66. And then 3 times 66 is the 198 you see right there. Okay, again, I'm leaving out just a little bit so it'll be readable, I guess. Now, so on the very next line, again, we use the cube of a binomial to get all of that. The 216 plus the 198, if you come to this next line, give you, see, 216 plus 198 is actually equal to 414. All right, and that's this value that you see right here. All right, now, what I did here is there are some terms that don't work out nicely. So, like, for example, this would be one of them. Well, the 108 root 11, where are we? Right here. Yes. We're okay. Oh, yeah. Sorry, y'all. Right here. This is 108 root 11 right here. Okay. That would be 36 times 3. That's the 108 root 11 that you see right here. Okay. And then root 11 cubed. All right. Now, so I have that just written down right here. All right. Okay. You got that? I think I do. All right. Now, so you got the 414. You have the 108 root 11. But notice you can write, and this one's kind of it slowed me down when I was first working the problem. This is 3 copies of the square root of 11, right? But that contains 2 copies of the square root of 11, which is 11. And so that's where you get this 11 root 11. You probably all see that, but just to be sure, there's 3 of them there. So that would be the square root of 11 squared would be in there, which is just 11, you see. Now that turns out to be super helpful because we have root 11 as a common factor here. And you see what happened here? The 414 remained. outside of the floor function. And then the root 11 is redundant, if you will. And that means you can use a distributive property. And so this 11 right here plus this 108 right here, 108, I got it there, yeah. 108 is the 119 you see there. So we got this thing all the way down to a natural number. And then we have the floor of the square root of 11 times 119. Now that's a little bit problematic if you're not using a calculator. Now you may be asking, okay, did you use your calculator here? Well, it's tempting. It'd be easy to say yes, all right. But this is believable. 3 squared is 9, right? So you expect the square root of 11 to be a little bit more than 3. How much? Now what I did, and this is tedious, and I didn't want to slow down the video. There's this process of a manual process where this was all done by hand. This is about, and this isn't even all the work, but this was done by hand. It took about 15 minutes. All right, but you see how we took right here. I don't know if we can get in here or not, but yeah. But anyway, that 9 is the perfect square smaller than 11, right? And so here's the work done to actually approximate the square root of 11. Now, it actually goes on and on and on. It's an irrational number, but we only need a little bit of precision here, maybe up to the 1,000th place. Anyway, this is how I found the cubed root, the square root of 11. This decimal representation you see up here is a good approximation for the square root of 11, all right? And again, that's a whole separate video. But anyway, when you carry out the work, and again, this is something that can be done by hand. I did not show that work, but the calculator was not required here. And the floor of 3.317, which is the decimal equivalent of the square root of 11, or the decimal, very close to decimal approximation. When you do the work and you round it down with a floor function, you actually get 414. And then the number you get here, I think, I can't even remember now. But anyway, the answer, ladies and gentlemen, is 108, is 808, excuse me. 808 is the largest natural number not exceeding this value right here. All right, I hope you enjoy.